In this lesson, we're going to learn about inductive and deductive reasoning. So when we can observe a pattern, then we can make a conclusion, and the conclusion or conjecture could be true or it could be false, right? So when we're making a general rule based on a pattern, you are using inductive reasoning. Now, the conclusion you make is based on a pattern is called a conjecture. A conjecture is an educated guess. It may be true or it may be false. It takes only one example called a counter example to prove that a conjecture is false. So let's go look at some examples here. In example 1, we have January, March, May. In this list, we're skipping February, and then March, and then April, we're skipping that, and then we'll make a conjecture then. We're gonna skip every other month. Every other month. Okay. So the next two items are gonna be based on our conjecture. After May, we're going to skip June, and then we're going to go on to July, skip August, and then it's going to be September. Okay. Now let's look at the other example. We have 6, 13, 20, and 27. And this sequence of numbers, how do we get from 6 to 13? And then from 13 to 20, and 20 to 27. Well, it looks like I'm just adding 7. So that's going to be our conjecture. We're going to add 7 to previous number. Now, what would our next two items be? Well, we stopped at 27, so 27 plus 7 should be 34. And 34, let's add 7, and we should get 41. Okay. So now let's look at example 2. But in example 2, after we make our observation, we make a conjecture, and we're going to determine if the conjecture is true or false. And if it's false, we'll add a counterexample. So these are all states, and they say that there are 6 letters for all these states' names. So our conjecture is going to be, well, it looks like all states have 6 letters in its name. So is that true? And if it's not true, we need one counterexample to make our conjecture false. So let's think of, let's say we live in Texas. How many letters are there? There's 1, 2, 3, 4, 5. So we have 5 letters. So this one counterexample is enough to say that our conjecture that all states have 6 letters in its name to be false. Okay. So now let's go to the next set of numbers. So if I look at these numbers, it's saying that, well, this angle here and this angle here, both of these are acute. They're less than 90. And when you add them, you still get an acute angle, less than 90, right? So if I look at all these, acute, acute equals acute, acute and acute equals acute, acute and acute equals acute. So now the sum of the measures of the two acute angles in our conjecture is going to be, well, it must be acute still. It's sum of the measures of the two angles is acute. So, is this conjecture true? Well, let's think of a counterexample. Let's look for some big numbers, right? So let's say 60 degrees and 50 degrees. Both of these are acute, and let's add them up, and we get 110 degrees. So 110 is obtuse. So this is one counterexample that makes our conjecture false. All you need is one. There are more, but all you need is one. So let's go look at deductive now. So deductive reasoning uses rules. We have facts, and we have definitions. Or we can use properties to arrive at a conclusion. So let's look at the situation here. Angie says, I've noticed previously that every time I kick a ball up, it comes back down. So I guess this next time when I kick it up, it would come back down too. Ricky says, well, that's Newton's law. Everything that goes up must come down. And so if you kick the ball up, it must come down. So who is using inductive reasoning? It's Angie, because she's using a pattern. Okay, so she observed that every time she kicked the ball, it goes down. So that's her pattern. Ricky, on the other hand, is using deductive reasoning because he's using Newton's law. So if you're using any kind of rule, fact, definitions, properties, you are using deductive reasoning. Now, with let me go to conditional. A conditional has an if and a then statement. The if part is the hypothesis. So it could be if it rains, right? So if it rains. Then is the conclusion, and let's see, if it rains, then I'll get wet. Right. So a conditional is a combination, or it's the if and then together. So if it rains, I'll get wet. Then I'll get wet. The law of detachment says that if your conditional is true, and your hypothesis is true, and hypothesis is true in an example or instance, example is true, then the conclusion must be true. Then the conclusion is true. Okay, so let's go into these examples. I have a conditional. Here's my if statement. Here's an if. Here's a then. So if the midpoint of AC, then AB equals BC. If B is the midpoint of AC, then AB equals BC. Okay, if is the hypothesis, then is the conditional, the conclusion. So it says here, well, if we say B is the midpoint of AC, then it must mean then that AB must be equal to BC. Now, if we look at example 4, same conditional, right? B is still the midpoint of AC, and AB equals BC. So same conditional, but now this time they've given us AB equals BC right here. Okay, so they've given us the conclusion. Can we still say that B is the midpoint? So let's think about this. Is there a way that AB is still equal to BC, but B is not a midpoint? So if you're thinking of just a straight line, then B will be the midpoint. But if you think of AB here and possibly BC here, so these two segments are congruent, let's say they're congruent, but because A, B, and C are not collinear, then B can't be the midpoint. So therefore, this is false. Our conjecture that B is the midpoint is false, if all we know is that AB is equal to BC. So let's go on here to the law of syllogism. This is still deductive reasoning. But we infer the hypothesis and the conclusion. Okay, so here's an example here. If it's raining, then it's pouring. If it's pouring, then the old man is snoring. So let me go back a little bit and say the law of syllogism is equivalent to the transitive property. This is where we say A is equal to B and B is equal to C. Therefore, A must be equal to C. So let's look at this problem right here. If it's raining, then it's pouring. I'll say this is A, this is B, and if it's pouring, same pouring, then the old man is snoring. That's C. So our new conditional, using the law of syllogism, is where we jump from the first hypothesis and pair it with the conclusion at the end. So the syllogism here is going to be, if it's raining, if it is raining, raining, then the old man is snoring. Okay, so notice that the pouring part is redundant. It's said 2 times. It's the same thing that's happening here. So you start with the A and end with the C. Start with the A, it's raining, and we end with the C, the old man is snoring. Now let's look at example 7. If two angles are not adjacent, then they are not a linear pair. If two angles are vertical angles, then they are not adjacent. So let's look for something that repeats. If two angles are not adjacent, then they are not adjacent. So they being the two angles. So these are actually our B's right here. This is a B and this is the B. So if we look at this right here, then it says if two angles are vertical angles, then they are not a linear pair. So we're going to take this as our hypothesis, our A, and then we're going to take this right here as our C. So we're going to write this as if two angles are vertical angles, then they are not a linear pair. Then they are not a linear